Hi everyone and welcome to Miss B Maths Teacher channel. Today I'm going to talk about application of sine functions, and you can see here an example, and it is about the height of the tide above mean sea level on January 24th at Cape Town, and it's modeled by this sine function. So and T is in meters, so where T is the number of hours after midnight. Before we go through this question, what I'm going to do first is I'm going to write down the general equation for sine. So it's y sine sin b x take away c close all these brackets and plus d. You may come across those a, b, c, d written in lower letters. It doesn't make any difference. So a it does affect, A affects the amplitude, B does affect the period, okay, it does affect the period. C is our, let's see, horizontal, it's horizontal translation, and D is our vertical translation. So, what does it mean? So if I do have, the basic one, it's not very good line, so it's equal like this. And if I'm just going to go like this, sort of, it's not the best graph, but yeah, it's okay. So let's say this is 2 pi. This is my period from 0 to 2 pi. Amplitude is the value, is the distance, maximum one or the minimum one, and between the maximum point and or minimum point and between the principal axes. So this line here is called principal axis. So, and in this case, principal axis is y equal to 0. So this is actually this number here, okay? So letter D. So one more time, amplitude is a distance between either maximum and the principal axis or minimum and the principal axis. So how can we find our amplitude? Usually we can look at the number there. So but pretty much amplitude is equal to maximum take away minimum over 2, and it's going to give you amplitude. So, and I have mentioned before, the period of periodic function is the length of one repetition or cycle. So this one here would be one repetition, 2 pi, and this is for, simple equation y equal sine of x. B does affect the period. So how do we find the period? It is equal to pi over b. In our case, in this example here, b is 1, so that is why we have the period 2 pi. For this simple one, sin of x, we don't have the value of c is equal to 0, which means that this graph hasn't been shifted horizontally, okay? There is no horizontal translation, and this d is 0 as well because we don't have plus any number, so therefore hasn't been shifted along the y-axis. A in our example here is a coefficient in front of sin, and in our case is 1, so which means here is going to be 1 and this one is going to be negative 1. Now I think we can start the question. Okay, so as I said before, the height of the tide above mean sea level on January 24th is modeled by this equation. T is the number of hours after midnight. So we do have to graph this equation for the values of T between 0 and 24. So what we can do, so we can, find the starting point. So starting point by having like t is equal to 0, h of t is equal to, you substitute all of this here. So pi times 0, all this is going to be 0. Sine of 0. So if you do need to have a look, you can use unit circle, but it's equal to 0. 3 times 0 is equal to 0. So that's going to be our starting point. You also you want to find the period. So, and we said before, the period is equal to 2 pi over b. So in our case here, pi over b, b is actually pi over 6. So it's the coefficient here of t. So it is, so you're going to divide by pi over 6, and then by just, multiplying, cancelling out, pi gone, so you're gonna have 12, and it says 12 hours. So that is our period. So please note, even though the day here it's 24 hours, the period is 12 hours. So, and then it's gonna have one more cycle. So when you look at the clock, so you're looking from 1 a.m. and then going the whole day until it reaches noon, and then starts 1 p.m. So that's gonna be another cycle. So now what I have done before, so actually I used Desmos. I'm gonna just write here what I have used. I have used Desmos to sketch this graph. If you are not able to use Desmos, often you are, able to use graphics calculator. You can use graphics calculator to sketch it. But let's have a look at this. So I'm just gonna insert this equation. Then we're gonna talk a little bit and just have a look if this is the right one. Yes, that's the one. I'm gonna make it a little bit smaller. So yeah, here's the equation. Now, looking at this one here, so we do have those maximums, and the maximum is happening here. So when t is equal to 3, when it's equal to 3. So, and that is this value of a in front of sin. This is our amplitude. So if I have a line going through, okay, and here, yeah. So this value is -3, and this is 3. So an amplitude is the distance between principal axis and maximum, or principal axis and minimum distance. So we're just gonna, it's absolute value. So it's not negative, distance has to be positive, so therefore it's 3. So again, we can see that amplitude, coefficient in front of sin, is actually telling us here, about, the amplitude, and the height, as here we don't have d, so this is our principal axis. So I do have a few more points here, so just in case we're gonna need it. So we may label this, A, B, however we want. So the maximum is at A and B, and minimum is at C and D, and the period is, we said 12 hours, so this is repetition of the cycle, that's 12, and then again the same, that's another one, that's 24 hours. So we do have 2 cycles in 24 hours. Okay, now let me have a look. When is high tide and what is the maximum height? I think I have already answered those questions, but high tide, so pretty much what they're asking, when is the maximum. So high tide is at 3 a.m. So if this is time 5, this is 10, 15, And this one is maximum. It is happening at maximum. So the high tide is at 3 a.m. and then here at 3 p.m. So the maximum height is 3 meters, 3 meters above the mean, as you know, seen at those 2 points A and B. If you need to find the value of t here, time, so actually it can be done. So you can use graphics calculator. So when you plug in your equation like this, I'm just going to show you that as well. So h of t is equal 3 sine pi times t over 6. So what we're looking for, the time when the maximum is reached, and we know the maximum is equal to 3, so that will be 3 equal to, and then 3 sine pi 6 pi t over 6 can be solved algebraically, can be solved using graphics calculator. So how are you going to do that? You go to gsolve, solve, and then you do find when they say x calculate, in our case is t, but they ask for x calculate, and they're going to ask you for y value, which in our case is going to be h of t. So, and then you're going to, instead of y, you're going to put 3, and it should give you x value, which in our case is the time and is equal to 3. Okay, now let's have a look at the next one. So what we have here now is the next thing to calculate is what is the height of the tide at 2 p.m. So at 2 p.m., which is time is equal to 14 hours, h of 14 is going to be equal to 3 sine 14 pi over 6. Using calculators, this is going to give you approximately 2.6 meters. So, and if you look at the graph, you can see, you know, it's approximately 2.6 meters. So to answer this question, the tide is 2.6 meters above the mean at 2 p.m. Now, let's do part D. So that's the last bit. And a ship can cross the harbor provided the tide is at least 2 meters above mean sea level when it's crossing possible on January 24th. So now what I have done, again, I have used Desmos to draw another graph. So this is what I have here. Let's see if it's gonna fit, how it's gonna fit. Okay, so what I have done here, so I have drawn another line because it says here in this question, a ship can cross the harbor provided that the tide is at least 2 meters above. So this is 2, this is 2, y equal to 2. So I have another line. So, and now it's telling me, you know, it says at least 2. So it needs to be at least or more than 2 meters. So, and it's going to happen, you know, between those times. So what we have here, so you can use calculators to solve it because you're going to have, you know, different values. So but here, you know, using calculator is going to give you, or Desmos is going to give you T1 is going to be another here T2, and then T3 and T4. So when is going to be safe? When T1 is equal to approximately 1.39 hours, T2 approximately, is this 4? Yep, that's 4. 4.61 hours, T3 approximately 13.39, and T4 approximately 16.61. So pretty much that it means that 139 hours is equal approximately 1 hour and 23 minutes. In case you're wondering, so 1 hour is this number here. It's 1 hour, and 0.39 hours, you just multiply by 60, and it's going to give you, you know, how many minutes. So this is time 1. So looking at this, and if you convert all this into, you know, hours and minutes, so pretty much is gonna happen this. So ship can cross between 1:23 and p.m. a.m. and 4:37. So this is a.m. and this is the part there, and then can cross again in this area here, so which is gonna happen, and let's use here and between 1:23 p.m. and 4:37 p.m. Okay, so it's gonna happen. So ship can cross, you know, twice a day. So between in the morning 1:23 and 4:37 minutes, and then in the afternoon again 1:23 and 4:37 minutes. Okay, so thank you for watching, and I'll talk to you soon. Bye.